All right. Well, good afternoon, everybody. Welcome to the flame working space. My name's Eric, and flame working is essentially just a style of glass blowing where we use a very focused heat source. So rather than big furnaces like what you see in traditional furnace-style glass blowing, us flame workers work over a more focused heat source. Nowadays, that comes from a torch. This torch here is running on natural gas and oxygen, and I've got it cranked all the way up right now. So the temperature of this flame is about 4,000 degrees Fahrenheit right now. And while that is a pretty outrageous temperature, I'm actually still perfectly comfortable back here. And there's so much oxygen pushing its way through the torch that it really helps to focus the heat. So the heat stays pretty well contained within the flame, and it's getting pushed away from me the whole time as well. So it's a lot more comfortable than it may sound when you just hear the flame temperature. Now the glass that I'm working with, these are solid rods of a type of glass that's known as borosilicate. And I know a lot of folks don't realize it, but there are many different recipes for glass out there in the world. There are actually thousands of different recipes for glass. And as you adjust ingredients in a glass recipe, you can wind up with some very different characteristics to the glass. And what is most notable about this glass here is the fact that it tolerates temperature change a lot better than most other glasses. And most glasses, if you heat or cool them too quickly or just unevenly, they're very likely to crack. But this glass holds up really well. There's a little bit of boron oxide that gets added to this formula. That is what makes the big difference in that tolerance for temperature change. And the reason this glass does have that sort of a characteristic is that it was initially developed to be used for making scientific laboratory equipment. So things like distillation units and reactors, even test tubes and beakers, all that fun stuff you find in a lab. And as you can imagine, in a laboratory setting, you're changing temperatures on materials all the time. And the last thing you want to have happen is for that equipment to start cracking while you're in the midst of using it. So this glass has been very important in supporting the sciences over the last century or so. It's also pretty handy stuff for artistic work. Since I don't need to worry so much about the glass cracking just because I'm changing temperatures quickly, it really frees me up so I can focus attention on other details of what I need to accomplish. So pretty handy glass for science and art. Now, I'm sure you guys are wondering what in the world I'm working on here, so we should get you clued in. This may look a bit like a chili pepper at the moment, but in a few minutes it's going to look a lot more like a dog. So that's the core of the dog's body. Now that I've got the core set up, I can start to build off of it. So I'm going to start with the hind legs, and I'll work my way towards the dog's head. So I have to make a whole bunch of attachments to get all the different details in here. Attachments have to happen when the glass is the right temperature. If either piece of glass isn't quite hot enough as I try to attach them, well, they're not going to fuse properly, and they'll end up falling apart as the glass cools back down. To judge temperature, you may notice I don't have a thermometer here. I judge temperature by watching how the glass is glowing and also sort of feeling out how it's moving. So as it gets hotter, the glass glows more and more brightly. Eventually it's so hot it almost looks like it's glowing white. That's when I want to make the attachment. That white hot stage, this glass is pretty close to 3,000 Fahrenheit. And it's about as soft as honey when it gets that hot. So the parts just sort of flow together like honey would. You get a nice, permanent, seamless attachment that way. So just getting the glass so hot it can really just flow right together. Okay, so we've got sort of the hip and thigh area on there first. Now that that's set up, we can start to build off of that. The lower leg is a little thinner than the upper leg, so I'm switching to a thinner rod of glass, and I'll turn the flame down a bit as well. So the torch It's a really precise and also really versatile tool. This torch here is essentially two torches in one. There's a really narrow flame in the middle, and then that center flame is surrounded by a couple of rings of openings for the gases. So it gives me the ability to make a lot of adjustments to the flame. I can adjust the size of the flame, the shape, the temperature, even the atmosphere, the sort of mixture of oxygen and gas that are running through there. So I've got a lot of control. And you'll notice I'll take advantage of that. I'll adjust the flame a lot as I continue through the process here. There's always the best flame setting for whatever action I might need to perform. And if you pay really close attention, you might also notice that I use different parts of the flame at different times. I don't always have the glass in the middle of the flame. The middle of the flame I use to melt the glass very aggressively. But as I'm working on the more delicate details, I use the edges of the flame a lot more. Like right now, so I'm stretching out the leg, just sort of working off the edge of the flame. If I try to control that in the middle of the flame, it melts too quickly to control. So you learn to sort of use different areas of the flame for different purposes. All right, so both the hind legs all set up. I'm going to add the tail next. And as I finish shaping the tail, I'm just going to leave it attached to this rod in my right hand. That rod then becomes my handle to support the piece, and I can start working towards the head. But first I need to clean this mess off of the end of the rod here. And you'll notice as I go along there are a lot of times that I sort of wipe off the tip of the rod that I'm sculpting from. I'm doing that to clean the glass. Sometimes there is actual dirt there. Sometimes there might be an air bubble trapped in the tip of the rod. Or more often than not, it's just a really odd shape on the tip of the rod. And I can work much faster if I just get rid of that oddly shaped piece. And then I've got a clean cylinder to work from, and I'll get much more consistent shapes to happen more quickly that way. So get this attached, setting up the heat just right so it will stretch properly for the tail. It's helpful if the handle is centered with the axis of the piece, so it turns more consistently in my hands. So that looks better. Now I can flip this guy around and start to work towards the other end. Immediately see I need to add a bit more material for the sort of the chest area. I'll build that up a bit thicker. So as this softens, I'll sort of maneuver some of that freshly softened glass to fill in the chest area. So I've been flame working for a little more than 28 years now. And I learned a lot of my foundation taking classes right across our back parking lot here at the museum. We've got a world-renowned teaching facility over there. We bring artists in from all around the world to teach their specialties right here in Corning. So it really is a great place to learn this stuff. We typically say it takes between about 4 and 6 years just to start becoming proficient as a glassmaker. There's a lot of feel involved with this stuff, so it really does require that you put in thousands of hours with your hands on the material to develop that proper feel for the glass itself, for the torch, for all the different tools and processes we use. So it takes a while. It takes a lot of dedication and perseverance. Some folks do have a better aptitude for this stuff than others, but really, even with an ideal aptitude, it takes years just to start getting the fundamentals down. So just removing this rod, and as I do that, I'm just starting to set up some of the material for the head. And since it's warm there right now, I might as well add a little more shaping there. Squeeze and a little push with these crimps that starts to set up the cheekbones and the eye sockets. But before I finish the details of the head, I want to add the front legs on there. softened up.
No, it's okay.
This attached. And you may have noticed I hold the piece upside down as I shape the legs. And I do that to take advantage of gravity. In this case, I want the shoulder to be thicker than the ankle. So as I hold the piece upside down and I'm pulling the rod upwards, more of that material falls down towards the shoulder. It falls away from the ankle, and I get the shape that I'm after. When you first start working with molten glass, a move like that takes a lot of thought, a lot of mental energy. But as you get more comfortable with the material, you tend to do it just intuitively. You're sort of in a flow with the material, and you just work with that flow. You don't have to overthink it so much. But it does take years to get to that point where it just sort of makes that shift from something you have to think about every single move to something where you're sort of feeling your way through and working more intuitively. That's when it gets a lot easier to talk as you're working. Alright, so I'll get this other leg on here. So the surface under my torch here that I keep using to sort of check the stance, it's graphite. Graphite is a really handy material when you work with molten glass. It accepts the heat really well, and no matter how hot the graphite gets, it'll never stick to molten glass. Most other materials, as they heat up, they do tend to stick to molten glass, and you can imagine that would be pretty tricky if your tabletop or your work surface was stuck to what you're working on. So graphite's pretty handy. We use it for work surfaces, we use it for some tools, and we use it for molds as well. Alright, so last few little details here. I want to add material for the dog's snout. Snout, and we need ears. So for the ear, I can just add a bit. Squeeze it flat, and shape it. First ear is pretty easy. The second one's a lot harder. So my view as I make that first ear is pretty straightforward, but then the second one, all of a sudden the piece is upside down. So I have to still be able to get the material in the right spot, get the proportions correct. And this is another weird thing that you have to get used to in order to be a successful glassworker. You have to learn to understand your work from very different perspectives. It's really rare as we're working on a glass piece that it is in the exact position that it's going to be finished in. More often than not, we've got it at some weird horizontal position, or it might be upside down or backwards, or we're turning it as we're working it. So you really have to learn to understand your work from all these different perspectives and still be able to get the right parts in the right spots, get the proportions right. All right, so yeah. Make a few thousand dogs over the course of 28 years, and eventually the ears do match. Okay. All right, so I'm just going to warm up my tweezers a little bit before I grab the body. The body started cooling a little. If I grab it with cold metal, there's a chance that could shock the glass, cool, or draw the rest of the heat out so severely that it cracks. So always wise to warm the tool a little bit. Melt this off the end of the tail. And there we go. There we go. Thank you. So, if you would like to take a closer look, by all means, feel free to come right up here. And if you guys have any questions for me, this is a perfect time to ask and answer. So stick around if you have some questions. I'm going to come out of the booth in a moment, be happy to answer them. And I hope you guys enjoy the rest of your afternoon here.